I got another Sony. This one's an SLVN750 that was brought to me with the top off. This one's completely dead. The guy that owns it thought it might be something simple. He thought it might be a fuse. So he brought it to me with the top off. That seems to be happening a little more often these days. I can't understand why that is, but anyway. This one, let's say, completely dead. We've got a power supply problem. Let's see what the fault is on this one and whether it's repairable. So first things first, we'll check for power supply voltages. Show my little power meter. Is there power getting to this thing? Oops. It says live. Okay. Oh, there's power getting to it. Let's check the power supply and see whether there's any DC voltage. That says AC. We should have DC there on the diode. Maybe that chassis is not. Yeah, that power supply is not turning on. We got no volts. We got no voltage whatsoever. A ground point here, and as you can see, the power supply is not working. It's measuring ohms because that's what it's measuring, the resistance of the power supply. I put it in DC mode. 0 volts, 0.2 volts. So this power supply is non-functional. I'll check the AC side of things over here, or the hot side of things. We'll just ground one of the probes to the capacitor here, and we'll check on the MOSFET. We should have high voltage on one of these ones. .163 volts. That's what we expect. So the MOSFET might be bad, but the oscillator's not running. And that would explain why it doesn't work. Now there could be another capacitor, little cap in here that's gone bad in the SMPS to start up. Because this thing didn't start, the oscillator didn't run, this cap will hold juice for a little while. As you can see, it's still got 148 volts on it. This will dissipate. There will be a resistor to pull this down, but when you unplug these power supplies, when they're running, they will discharge very quickly, but if they're not oscillating, that high voltage will stay there for a while. As you can see, it's been unplugged now for close to a minute. Still has over 100 volts. So you have to let these discharge or short the capacitor out and kill it. But they will discharge on their own. As you can see, the voltage is constantly dropping. By the time I get the chassis out and get the board out, this thing should be safe to look at. Do we still have a charge on this cap? 10 volts. That's not going to hurt you. It could be the IC that's bad, but it also could be could be solder connections, it could be caps. First thing I notice on the board here is there's one connection here that doesn't look like it's soldered properly. That's the first thing I noticed. But I want to check the what they call the bootstrap cap. That's what gives it a pulse to get things going. It could be the IC that's bad. That's for sure. That's the real possibility that the IC is cooked. The cap I want to check is this one. I think it's right down here. Oops, that wasn't supposed to happen. I think my solder tool needs to be cleaned. Seems to be leaving more on the board than it's taking away. This is the one that I suspect might be problematic. I might be way off base, but these are usually the ones that cause us trouble. What this cap does is it's a small cap that just provides a pulse when the unit power is first applied. And they're typically like a small capacitor, 50 volts, 4.7. What they do is when the power is first applied, they apply a pulse to get the oscillator running, and they dry up. And typically the system, when they go bad, is that the unit's fine until the power is removed. And like during a power failure, or if someone moves it from one room to another, and then the power comes back and it doesn't start. Of course, people that have these old machines and they put them away and they haven't used them for a while, and they go to power them up, and they're dead. Now this is not bad. This is 1.6 ohms, and this is a 4750. So 47 or 4.7 at 50. Sorry, for 4.7 at 50, you know, it would be 4.2 would be considered good. This is measuring down at 1.5, 1.7. Is it shorted? They can short too, but we can check that. We can check that for a short. Here, if I go to my ohms setting, and we can just check and see if this cap's shorted. So there's no short on this cap, so this cap's fine. 82 mega ohms is going to go 90 mega ohms. The nice thing about this meter is it really has high rate readings for resistance. Put the capacitor tester on, and it's 4.8 microfarads. So this one's right within spec. No issue with this one whatsoever. So it's not the capacitor I thought it might be. It's probably the oscillator itself, which is all part of the IC. I'll put this back in. Could have been that connection, but I doubt it. It might be this IC here, which I don't have. They're not expensive, but I don't know that I want to order one in. VHS VCRs are a dime a dozen, so there's also little resistors that can go open that will cause it to not run. There's a couple of little resistors down here that provide the bias signal to start it up. We'll check them. There's a few little resistors down here that could certainly create a no start condition. Should be a 470 ohm. That looks to be right. This other one here, this other one's a 1 meg ohm resistor, so I had to undo one side just so I can measure it. Oh, you guys can't see the meter, but it's 1 meg ohm. Doesn't get any closer to a meg than that, so that resistor is okay. I think it's probably this. It's probably this IC that's bad. This is the block diagram for this chip, how it works. So basically, you've got a source and a drain because it's a MOSFET. So your source is pin number 1, which is this one right here, and the drain is pin number 8, which is that one over there. And 7 and 8 are both connected together. 6 has no connection. 5 and 2 are ground, and you've got an input. You've got your input voltage in to operate the chip is pin 3, and pin 4 is your overcurrent protection, which are these pins down here. So let's just take a look at pin 3 and 4 on this side. We should have a voltage on pin 3, which biases it to operate. Pin 4 is overcurrent protection, so if that is pulled too high or too low, it's going to shut it down. And I think that's also what's also using for the reference, if I'm not mistaken. Let's get the schematic up here again. Overcurrent protection is pin 4, and that's also your feedback loop for your voltage control. That controls your pulse width modulator. Here's the schematic for it, right? So pin 1 is your input for internal bias, so internal regulator. That needs voltage to run. If that doesn't have any power, the chip's not going to start up. And you've got over voltage protection here, which will latch it and kill it if it goes too high. There's over voltage protection, and you've got overcurrent protection here, which will also latch it and kill the oscillator. So the oscillator is going to run when it gets its regulation. It's going to run the drive. So basically, you give it voltage, and it should run on its own. So let's just we'll make some voltage measurements. I'll power this thing up, and I'll clip onto the power supply here. We'll do some voltage measurements and see whether we're getting our input voltages on pin number 3 and our pin number 4, our overcurrent protection, to see whether it's trying to at least try to start the unit up. It could very well be the chip, but it could be also external control if it's not getting the startup voltage. Pin 3 is the one that capacitor filters, and it's got its own voltage source over here, right? It comes in through this resistor. So, I mean, even that resistor could be bad. And we'll check the voltages here. So let me just clip my meter on to the ground, hot ground. This is all the hot side that we're going to be working on. My power cord. Okay, we'll give it power, and we're going to measure pin 3, which is this one right over here, which is going to this capacitor, and I got nothing. I got nothing on pin 3. I got 2.6 volts there. I have 0 here. Why is it 0? Is it shorted internally? Well, there is a diode over here. Is this diode shorted? Well, that would explain why it doesn't start. Could be this IC could be shorted too. Okay, let's just power this down. I got no starting voltage, so it could be the IC itself is hooped. This cap is going to be charged now, so I don't feel like waiting for 10 minutes for it to discharge. So we'll just discharge that cap. I want to check this diode over here, this phototransistor over on the, this is the optocoupler. Is it shorted? Shouldn't be, but something's pulling that voltage down to nothing. We do have voltage here, biasing it, but on this side it's 0. That's a diode. No, it's not shorting. There's no leakage. Next step in troubleshooting will be to disconnect pin number 3 from the IC, which is the voltage input, and we'll see whether the bias voltage here comes back, because that was sitting at 0. I want to make sure that the chip itself is not shorting it down to ground. So with it disconnected, I see 42 volts here. So I think the chip itself is shot. You see, we've got lots of power here being pulled up to start that chip running, but the chip's not running. It's pulled down to nothing. I gotta wait for this to dissipate now, or short it out, one of the two. Once again, I've reconnected the chip. We'll just monitor this voltage here when I plug it in. This voltage should go up to a couple volts for the thing to start, and it's not going to rise because I think the chip itself has got a short in it internally. Even though when I measure it with the meter, it doesn't measure that it's got a short. It sure looks like it's got a short. See, nothing. You got like 0.02 volts. That chip should that should be higher than that. That should probably be around 6 or 7 volts, and that chip should start up. So we got a bad chip on this one. At this point, I'm going to condemn this unit. I mean, the IC itself is not an expensive part, but the problem is, by the time it gets shipped here, it's not economical to repair. I mean, after all, this is just a basic VHS machine. There's nothing real special about this. These things are a dime a dozen, so I'm just going to not repair this one and send it off to recycling, because that's about all it's good for. As always, thanks for watching.